This video is part 2 of the Chapter 3 review. It is entirely of the proofs, questions number 22 through 30. Let's begin. Question 1, you notice that Q is the center of the circle, and you have angles 3 and 4 being congruent. You should notice that there is not two triangles in this question, so you cannot prove two triangles congruent. So let's mark up the picture. If if the center of the circle is Q, you know there's the radii rule. So that's what's given. We want to prove that the big angle, let me switch colors here. The big angle here is congruent to this big angle here. Well, what do you notice? When you do that, oh, if I could get 1 and 2 to be congruent, then I could add 1 and 3 and 2 and 4 to get the bigger angles. Well, if you notice the two sides are congruent, you know then these two angles will be congruent. So what does this proof look like? You start with circle Q. Reason 1, you can say QB is congruent to QC. From there, reason 2, you can say angle 1 is congruent to angle 2, because if sides, then angles. Then we can add 3 and 4 to those two and end up with ABC being congruent to angle DCB. 3 reasons. First one is all radii congruent. 2 was if sides, then angles. And 3 would be the addition property. Moving on, question 23. This is a three-dimensional picture with a circle on it. This is a line going through it. There's a triangle up here. Let me highlight it. There's a triangle up here on top of the page. And there's a triangle down here on the bottom of the page is what we're looking at. If C is the midpoint of BE, so here's BE, C is the midpoint, causing these two to be congruent. BE is perpendicular to AC, BE is perpendicular to AC, causing a right angle at 1. And CD, so this is a right angle, 1. This one is a right angle at 2. And then I know the center of the circle is C, so this idea gives me the radii. If C is the center of the circle, it gives me AC being congruent to CD. How are these two triangles congruent? Side, angle, side. So C was the midpoint, causing reason 1, which is BC being congruent to CE. The angles came from the BE being perpendicular to AC and CD being perpendicular to BE, causing this rule 2, a right angle at 1, same reason, right angle at 2, and we can put these together and say angle 1 is congruent to angle 2. And then we use the circle C for reason 4, AC being congruent to CD for all radii are congruent. Bracket it together. We just proved triangle ACB being congruent to triangle DCE. We go on angles 4 and 6. Well, you notice 4 and 6 are not in the triangles. What two angles are to use CPCTC? That's correct, angles 3 and 5. But wait, what's special about angles 3 and 4? Well, from the diagram, reason 7, you know that angle 3 is vertical to angle 4. And also from the diagram, you know that angles 5 and 6 are vertical. So if 3 is 5 and 3 is 4, and 5 is also 6, that means you know all of them are congruent together. Reason 8, we can prove angle 4 congruent to angle 6. I know that proof was long, but every step you have done before. Step 1 was definition of midpoint. 2, def of perpendicular. 3, all right angles are congruent. 4. All radii congruent. 5. Side angle side. 6. CPCTC. 7. Vertical angles congruent. And 8 is the transitive property because they were all congruent. 24. We got BQ perpendicular to AD, causing a right angle at 1. BR being perpendicular to DC, so that's a right angle at 2. B is the midpoint of AC, causing these two pieces to be congruent, and then QB being congruent to BR. Well, you notice you can put these two triangles together. You look at it, and across from angle 1, AB is marked congruent, so that is the hypotenuse. So you know this has to be HL, and then we'll put a triangle to make sure we don't miss the triangles. The hypotenuse came from B, was the midpoint, which gave me AB being congruent to BC. The leg was QB being congruent to BR. And the right triangles come from the perpendicular. This one gave me, for reason 2, right angle at 1. This one, reason 2, gave me a right angle at 2. And then instead of saying all right angles are congruent, we want to state that triangle AQB and triangle CRB are right triangles. Bracket it all together. We can say that triangle AQB is congruent to triangle CRB. Next is CPCTC. AD is not a side in the triangle, so you have to come up with another strategy. The other strategy is using that idea of sides and angles. Angle A is in this triangle. Angle C is in this triangle. So angle A is congruent to angle C. What's special about that? Well, what do you notice? If you have two angles, then you end up having two sides. Reason 6. AD is congruent to DC because if angles, then sides. Reason 1 is midpoint, definition of midpoint. Reason 2, definition of perpendicular. 3, definition of right triangle. Reason 4 is HL. Reason 5, CPCTC. And reason 6 is if angles, then sides. Confused yet? Hopefully not. Hopefully you are staying with me and you're getting them right for the most part. Moving on, AD for 25 is congruent to ED, and angle A is congruent to angle E. What else do you know? Ooh, angle 1 and 2 are vertical. Now you can see that you can prove the triangle over here and the triangle over here are congruent by angle, side, angle. So A is congruent to E. The side was AD being congruent to ED. And the other angle came from the vertical. So from the diagram, reason 1, angle 1 was congruent to angle 2. We just proved triangle ABD being congruent to triangle EFD. We want 3 and 4. Ooh, they're not in our two triangles. But we just kind of went over this idea. So for CPCTC this time, why don't we take this side here and this side here to be congruent to each other? And then if the sides are congruent, then you know these two angles end up being congruent. So we get BD being congruent to DF, which then gives us angle 3 being congruent to angle 4. Question 6, angle ABD, this big angle here, is congruent to this big angle here. Angle 6 is congruent to 7, and then AB is congruent to BC. Our goal is to prove this triangle here, congruent to this triangle here, and then get AF and DC. But what do you notice? You got one side marked. We can get this angle because angle 4 is reflexive. And if we subtract it, we could get this angle and this angle. So we got side angle. And then we need another side or angle. We can't get another angle, but we can look at triangle BFD and say it's isosceles. So if the angles, then this side will be congruent to this side. So we can prove it by side, angle, side. So one side was angle 6 was congruent to angle 7. Arrow out. We got BF congruent to BD. The angle came from angle ABD being congruent to angle CBF. And then from the diagram, reason 2, angle 4 is congruent to angle 4, which then reason 3 gives me angle 3 congruent to angle 5. And the other side was given as AB being congruent to CB. Got it all? Bracket it together. Up to reason 4. Triangle ABF is congruent to triangle CBD, which then we can just go and finally, one of them ends with CPCTC. Reason 1 was if angles, then sides. 2 is reflexive. 3 was subtraction. 4 side angle side, and 5 is CPCTC. 27. AB perpendicular to BE, a right angle at B. EF perpendicular, right angle at E. AB being congruent to EF, and then AC being congruent to DF. Let's look at it. We got the right angles. Do we have the hypotenuses? Yes, we do. They're across from the right angles right here and here. So this has to be HL triangle. The hypotenuse is AC being congruent to DF. The leg is AB being congruent to FE. And the perpendiculars give us the right angles for the right triangles. This one gives me, for reason 1, right angle at B. Same reason, right angle at E. And then we can say triangle ABC and triangle FED are right, which then states that they are congruent. Which now we got to use CPCTC. So I can say BC is congruent to DE, which is not what I want. I want this overlapping piece here and this overlapping piece here, which means you realize that they share this piece. So after CPCTC, We can use the reflexive piece of CD being congruent to CD. These two together. Reason 6, we can say BD is congruent to EC by addition. Reason 1, def of perpendicular. 2, def of right triangle. 3, HL. 4, CPCTC. 5, reflexive. 6, we did addition to make something bigger. Question 28 is three-dimensional. What it is A is off of the page. It is not on the page. B, C, D is on the page. So we need to look at it in two ways. That we have a triangle, A, B, C. And we have a triangle in the back, which is called A, B, D. When we mark up the information, we got AC and AD. We got this giving me a right angle here, and this one giving me a right angle here. And what do they both share? They both share side AB, so we can prove these two triangles by HL. The hypotenuse is AC being congruent to AD. The L is from the diagram reason 1. AB being congruent to AB. And the right angles come from the perpendicular. This is a right angle. ABC is right. And angles A, B, D are right. Gotta use HL, so then we can say that triangle ABC and triangle ABD are right triangles, which then means that ABC is congruent to triangle ABD. Now, what do we use for CPCTC? 1 and 2 are on the base. They're on the ground. They're on this other triangle, CDB. So this is 2, this is 1. They're on the ground. But what do you notice? We can take BC and AD from the two triangles we just proved. And if those two sides are congruent, you know those two angles are congruent. So we can say BC is congruent to BD by the CPCTC, and then we can say angles 1 are congruent to angles 2. 6 reasons. Reason 1, reflexive. 2, def of perpendicular. 3, def of right triangle. 4, HL. 5, CPCTC. And 6, if sides, then angles. Two left. We got G as the midpoint. These two are congruent. E is the midpoint over here. And then AGH is congruent to EI. So that means, whoa, all 4 are congruent, plus this big piece and this big piece by like multiples. These 3 together give me like multiples. AB is congruent to CD, which we can get this side here and this side here because we know this piece is reflexive. And then HC, which is the third side here, and this side here are also congruent to each other. So we can prove these two triangles by side, side, side. Let's do the like multiples first. G is the midpoint of AH. E is the midpoint of DI. And GH is congruent to EI. Those 3 together. Reason 1, like multiples, AH congruent to DI. Second segment, I can say that HC is congruent to IB. That's great. So these three go for the first segment. This one goes for the second. And then the third one, we got AB congruent to CD. And then the reflexive piece of BC being congruent to BC. We can add and say AC is congruent to BD, giving me reason for triangle ACH being congruent to triangle DBI. Reason 1 is like multiples. Reason 2 is reflexive. 3 is addition. And 4 is side, side, side. And finally, number 30. BW congruent to CW. And what do you notice about that triangle? Those two sides are congruent, which means the two base angles here end up being congruent to each other, because if sides, then angles. And then we got side BF here is congruent to this side here. And last but not least, AB is congruent to CD, which means this side will be congruent to this side by the overlapping of BC. We just are now able to prove that triangle ACE is congruent to triangle BDC by side, angle, side. The first side, we'll do the addition part. So AB is congruent to CD from the reflexive. BC being congruent to BC. We add and say AC is congruent to BD. The angle came from if BW was congruent to CW. If sides, then angles 1 and 2 are congruent. And lastly, was BF was congruent to CE. These three things together. Reason 4, we just proved triangle ACE congruent to triangle DBF. Now here's the tricky part. We want to prove this very large triangle is isosceles. Well, to do that, you need two sides congruent. So we cannot steal sides from these two triangles being congruent. So you have to think of that rule if angles and sides. So this angle and this angle are congruent. So angle A is congruent to angle D, which means if angles, then this side and this side are congruent. We're up to reason 6. AG congruent to DG. And we ran out of room, and if those two are congruent, we got reason 7 that triangle ADG is isosceles. Reason 1 was reflexive. Reason 2 is addition. Reason 3 is if sides, then angles. 4 is side, angle, side. 5, CPCTC. 6, if angles, then sides. And 7 is definition of isosceles triangle. There's your lesson on proofs. There's all of them done for you. Hopefully you enjoyed them. Hopefully you did them fairly well. And good luck to you on the upcoming test.